Hello students, I am Krishna Nayak, your chemistry teacher. As we know, today we all are fighting with corona, and for that you have to stay at home and stay safe. But don't forget that you all come in a standard 12. I know you might be in a vacation mood, but with the enjoyment you have to give me at least 1 hour daily. Because from today we are going to start chapter number 3, Electrochemistry. I am starting this chapter because it's quite easy and you will easily understand this chapter by my videos. If during video you met with any queries, then message me. Don't worry, we will discuss only one topic daily. So let's start electrochemistry. Electrochemistry is made by two different words. One is electro and second is chemistry. Electro is related with the electricity and chemistry is related with chemical reaction. Means electrochemistry is a study of interrelationship and interconversion of chemical energy and electrical energy. Means in electrochemistry we have to study the interrelationship, right, between chemical energy and electrical energy. Means in electrochemistry we study the relationship between correlation between the electricity and chemical reaction, and also we can interconvert, right, means we can convert electricity into a chemical energy and also convert chemical energy into electricity. This type of study is related in electrochemistry, right? Now, as we said, chemical energy is converted into electrical energy and electrical energy converted into a chemical energy. For this conversion, we need a device, and that device is known as cell, right? If we are converting chemical energy into a electrical energy, then this device is known as galvanic cell, right? And if we are converting electrical energy into a chemical energy, then this device is known as electrolytic cell. Now we will discuss the main difference between the galvanic cell and electrolytic cell. Further points we will discuss after the study of galvanic cell and electrolytic cell in detail in this chapter, right? Then as we say that in galvanic cell, the chemical energy is converting into electrical energy. So we can say that in galvanic cell current is produced, right? While in electrolytic cell we have to use electricity, right? Because we are converting electric energy into a chemical energy, right? Second, in galvanic cell the spontaneous reaction occurs, right? A spontaneous reaction means the reaction which done by themselves, right? Suppose we take one beaker in copper sulfate solution is there, and we dip the zinc rod in this solution. We know that the copper solution having a blue color, but after some time we can observe that this blue solution is disappear, right? Because this zinc replace the copper, right? And we will get the reddish brown precipitate of copper, right? Means the reaction between zinc and copper sulfate, the displacement reaction is occur by itself, right? This type of reaction is known as spontaneous reaction. Means in galvanic cell, spontaneous reaction occurs, and due to that spontaneous reaction we can produce the current, right? While in electrolytic cell, for the carried out non-spontaneous reaction we have to use electric current. Example, we want to decompose the water. For that we take a water in a one beaker. Suppose we put that water for 1 day, 2 days, but it does not decompose by itself, right? We know that. But for the decomposition, we have to arrange a cell like this, right? In this we take 2 platinum plate and it is connected by battery, means we are providing electricity. If we provide electricity, this water is decomposed to a oxygen and hydrogen, right? Means decomposition of water is not occur by itself, so it is a non-spontaneous reaction. So further carried out this type of non-spontaneous reaction, we have to use electricity, and for this we form a one device, and this device is known as electrolytic cell, right? The example of galvanic cell is cell batteries, which we use in a calculator, watches, right, car. They all are galvanic cell. And electroplating, metal purification, right? You studied in a low standard about that. That type of cell is of electrolytic cell. We see the what is electrochemistry, but main question arises that why the study of electrochemistry is important. Answer is that electrochemistry having a significant role in our everyday life, right? In our everyday life we use calculator, clock, watch, mobile camera, torch, remotes, car, right? In this type of thing we use cell or batteries. Batteries is nothing but a group of cells, right? Means we everyday using electrochemical cell, right? And if we are using electrochemical cell, we have to know about how they made, how they work, right? So study of electrochemistry is important. Second thing, rusting of iron. You will surprise by knowing that when iron rusts, it forms electrochemical cell, right? Means rusting of iron is also one part of electrochemistry. And if we have to prevent that rusting, we also have to know about electrochemistry, right? Then electroplating, purification of metals are also possible by the help of electrochemistry. Now, nervous system. We know that our organ sends some signal to our brain, and it interprets that signal and give the response to our organ, right? The all control done by the nervous system in our body. In this process also there is a formation of electrochemical cell, right? So for the study of this nervous system, you also have to know about the electrochemistry, right? And as we earlier discussed, we can produce the electricity, right? And the production of electricity by this method is eco-friendly because there is no use of any hazardous reagents, or there is no byproduct. So it's an eco-friendly method for the production of electricity, right? Hope you understand. If electrochemistry having so many applications, means we have to necessary to study it, right? Now we will discuss about what is cell, how cell is formed, right? Which type of substance are used in the formation of cell, how it work, right? Here it is a half cell, right, in which we use electrode and electrolyte. By the help of this type of material we can form the half cell, and by the help of this type of two half cell we can form a cell, right? Now we will discuss what is electrode and what is electrolyte. Electrode is a solid electric conductor that carries electric current. Means electrode carries electric current, and as an electrode we can use a film or plate of metal, right? In electrochemistry, that electrode provides a surface for the reduction and oxidation reaction. Electrode having two types, first anode and second cathode. Electron on which oxidation reaction take place, right? Oxidation reaction occurs, that electrode is known as anode, and the electrode on which reduction reaction take place is known as a cathode, right? Here oxidation reaction is occurs at anode, and oxidation means losing or donating of electron, right? Whereas reduction reaction is occurring at cathode, and reduction means accepting or gaining of electron. You can remember that term by anox, red cat, right? An means anode, ox means oxidation, means oxidation occurs at anode. Red cat, red means reduction, and cat means cathode, means reduction reaction occurs at cathode, right? Now electrolytes, a substance that dissociate into ions in a solution or molten state to conduct electricity is known as electrolyte. Means electrolyte is a salt which is dissociated into its ion if we take the solution or a molten state of that salt, right? Suppose we take a solution of NaCl. Right, in solution this NaCl converted into Na plus and Cl minus, and due to these ions it conduct electricity, right? Means from the solution of NaCl electricity can be a pass, means that type of salt are known as electrolyte. Non-electrolytes. Non-electrolyte means the substance which remains same in the molecule and do not conduct electricity from it is known as non-electrolyte, right? Exact opposite of electrolytes, sugar, alcohol, glycerol, etc. are non-electrolytes. Now we will discuss about galvanic cell. First, what is galvanic cell? It is a device in which chemical energy produced in a spontaneous redox reaction changes to electrical energy, right? Means galvanic cell is a device in which we carried out some spontaneous reaction. We already discussed about spontaneous reaction, right? Reaction which carried out by itself is known as spontaneous reaction. Redox reaction means oxidation and reduction reaction take place simultaneously is known as redox reaction. Means we have to use that type of reaction which done by itself, right? And due to this reaction we can produce electricity, and for this all process we form a device, and that device is known as galvanic cell, right? If we take zinc and copper for the formation of galvanic cell, it is known as the Voltaic cell, right? It is our zinc copper cell, galvanic cell, right? In which we take one beaker in which we fill up the ZnSO4 zinc sulfate solution, and zinc rod is dipped in this solution, right? In other part we take other beaker in which copper sulfate solution is filled up and copper rod is dipped. It is our 1/2 cell and it is our 2/2 cell. When we connect this 2/2 cell by a circuit, is form a 1 cell, right? Now we will see what type of reaction will occur. We know that here zinc is more reactive than copper, so zinc will be displace the copper. So at the zinc half cell, that zinc electrode converted into Zn+2 and donate electron, right? Means from this rod, Zn+2 ions goes into a solution and electrons will be released. That electron travel through this circuit, right, and come at this electrode, right. Now here we having copper sulfate solution. Copper sulfate solution means Cu+2 and SO4-2 ions are there. That Cu+2 ion accept this electron and convert it into a copper, right. You can see that Cu+2 ion accept electron and converted into Cu. Here zinc is donating electron, and donation of electron is known as oxidation. So it is our oxidation half cell, and we can say that it is our oxidation half reaction, right. Same here, copper is accepting electron, and accepting electron or gaining of electron is known as reduction. So it is our reduction half cell, and this is our reduction half reaction, right. As we discuss, oxidation always take place at a anode. So zinc rod will be our anode, right, and here reduction reaction is occurring. So copper electrode will be our cathode. Now during the reaction there is a releasing of electron. So there is so many negative charge. So our anode will be a negative, and here accepting of electron. So our cathode will be positive, right. Now during reaction, electron pass from anode to cathode, and due to the flow of electron there is a production of current, and it will be a flow from cathode to anode. Now in initial, when we take a ZnSO4 solution, we know that there is a concentration of Zn+2 is equal to concentration of SO4-2, and concentration of Cu+2 is equal to concentration of SO4-2. But when we connect that to half cell and reaction start, at anode that Zn donate to electron and converted into Zn+2. That Zn+2 goes into the solution. Means after some time there will be a high concentration of Zn+2 as compared to SO4-2, right. And at this site, Cu+2 accept electron and deposited at cathode. So there will be a less concentration of Cu+2 as compared to SO4-2. Means after some time there is a generation of unneutrality in the solution, and due to unneutrality that reaction may be stopped, because if this side the concentration of Zn+2 ion increase, it not allow to electron to go from here. And if here SO4-2 concentration increase, it not allowed to come to the electron, right. So maybe cell does not work after some time, and for that we use a salt bridge, right. We use a salt bridge. You can see that salt bridge. Salt bridge is nothing but U-shaped tube, right, in which agar-agar solution plus inert electrolyte is filled. This is used for gaining electrical neutrality in both half cell, right. Because in salt bridge we using inert electrolyte, means if we use KCl, then during reaction that inequality is generated, right? Here Zn plus 2 concentration increase. KCl provide this Cl minus ion to this solution, so it becomes neutral. Same here, SO4 minus 2 charges increase, so K plus neutral this solution, right? Means we can gain electrical neutrality both side, and this cell can work again, right? Means salt bridge complete the circuit and it provide neutrality both the cell, so chemical cell can be work. Here you have to remember that in electrochemical cell, oxidation always take place at the anode and reduction always take place at the cathode, right? Here oxidation involves loss of electron, and due to that electron, our anode will be negative and our cathode will be positive, right? Here the flow of electron will be from anode to cathode and current will be flow from cathode to anode, right? We'll discuss about the salt bridge. Salt bridge is a U-shaped glass tube filled with inert electrolyte mixed with substance like agar-agar or gelatin with which makes it jelly-like, right? This type of substance used to form electrolyte as a jelly-type substance, right? The electrolyte filled in salt bridge does not take part in a redox reaction, right? We have to use that type of electrolyte. We use the word inert electrolyte, right? Because we have to use that type of electrolyte which do not participate in the redox reaction, right? The electrolyte should have the same cationic and ionic mobility. Same cationic and ionic mobility means we discussed that for the electrical neutrality, this electrolyte provide the cation and anion. If here KCl solution, K goes to this side of solution and Cl goes to this side of solution, right? If they both having different mobility, right? If Cl having more mobility than potassium, means Cl will be reach here faster than K. Suppose 10 Cl reach and neutral Zn solution, but mobility of potassium is low, then it travels slow. Means when 10 Cl comes to this side of cell, only 5 K plus reach this side of cell, right? Means we can't maintain the neutrality, so mobility of that two cation anion will be same. So we can use KNO3, NH4NO3, KCl, NH4Cl type of electrolyte as the inert electrolyte, right? We can't use the Cl minus ion having electrolyte during using of silver cell, because that Cl will combine with Ag and give a precipitation of AgCl, right? Now discuss the function of salt bridge. The salt bridge complete the electric circuit, right? And it maintain electrical neutrality by the movement of ion from one solution to another solution, right? Without mixing to solution. Hope you understand about the electrochemistry and galvanic cell, right? If there is any query, then message me and wait for next video.